Hello, it's Keith here, and this is lesson 86 of the platform-specific series of my Z80 assembly programming tutorials. Now, we're going to be looking at interrupts today, and what we're going to do is we're going to take the previous example, the Mintal graphical example that we looked at before. We're going to add sound to it. The music's going to be generated by my ChibiTracks music player. That's covered in a totally separate tutorial series. So let's first just quickly fire up the example so you can actually hear it. So we're going to try this out on the Sega Master System here. Hopefully you can hear the music there. So this is the example, and so we've got graphics and movement and sound now. So this is really the sort of skeleton framework for a simple game. That's the intention anyway. So we're going to look at the sound today. We're going to look at how we're actually getting the interrupt working. That's useful to you if you're looking to use your own music software. And then I'm just going to briefly discuss the parts of the ChibiTracks music software that I wrote that are incorporated in this, just so it's a complete example. So there we go. So let's go over to the source code and let's take a peek. Okay, so we're looking at the file SMS Mintal with sound here. So that's what we've got here, and we've got all of our graphics code, which we're not going to discuss. There's a whole tutorial series on that. What we're going to discuss is what it's taken to get interrupts working correctly on this system. Now, the first thing you need to bear in mind with this system is the interrupts are generated by the graphics. We're using VBlank. That occurs once per frame, and that's a great way of timing music to make it play consistently, irrespective of what our game is doing. If our game's getting slow, the music does not. That's a good thing to have. But what we need to do is we need to turn on the actual interrupt, because by default it might not actually be playing. So if we've got interrupts disabled in our VDP settings, we're going to have no music, and that could get quite confusing. This is something that caught me out, which is why I'm making it quite clear. So basically it's bit 5 here of the VDP register 1 here. So if I change this to a 0 here, and I just run my program again, well, the program's running fine, but you can hear we've got new music. So that's a real sort of gotcha that I just suggest you sort of keep an eye out for, because that could catch you out. So that's how we tell the hardware to generate interrupts. On the Sega Master System, we're using interrupt mode 1. Interrupt mode 1, whenever an interrupt occurs, it calls to memory address 38 in hexadecimal at the base of the system. So the base of our system memory is actually our ROM cartridge. So all we need to do is put an interrupt handler jump in the right position in our ROM cartridge, and that's what we've got here. So at 0038, we've got the jump to interrupt handler and just some spacing until the next the NMI, which is actually the pause button on the Master System. That's worth bearing in mind as well. That actually generates an NMI every time you press that pause button, but that's not what we're looking at today. So this is defining the pointer to our interrupt handler. How do we actually get the interrupt handling set up? Well, just for safety, because we're on a piece of hardware that doesn't necessarily have a firmware, we don't know how it's going to start up. We're setting interrupt mode 1. We're enabling the interrupts here. So the way the Master System works is an interrupt, when it occurs, because of VBlank, will be queued up, and that will try and occur. But if interrupts are disabled, it won't occur. It will just wait until interrupts are re-enabled, and then it will fire even if it was delayed. Some systems don't do that. Annoying systems like the Spectrum, Sam Coupe, if the interrupt's missed, it never happens, and that means that if you disable interrupts, your sound can get slow, which is not really the point of interrupts. Interrupts are in my mind, are supposed to be something you can more rely on anyway to occur anyway. So our interrupt handler has to do one job for the hardware. Now, as I say, the interrupt will actually wait to fire even if interrupts are disabled, but it will actually wait until we tell it it's been processed. If you don't do this, you're going to get very fast music and no gameplay. So here's our interrupt handler. We're backing up the main accumulator here by using the shadow registers here. And we've got this command which we're reading in from VDP control. Now this actually reads in the status register. Now if I disable this line here, reading in from the status register confirms that the interrupt has been processed, and if we don't do it, you saw there, the game locks up and we just get the sound playing super fast, and that's because we didn't register that the interrupt had been processed with this line here. Now the rest of the code here is actually relating to my ChibiTracks software. ChibiTracks uses the main registers and IX. It doesn't use IAY, and it doesn't use the shadow registers. So we're just pushing the regular registers on here and popping them off again. And our shadow registers are actually free for the rest of our code. But there are a couple of things that we need to make sure our code isn't doing that would cause interrupt problems. Now, the one that I found was causing some problems for this code was basically when we're selecting the VRAM destination, we're writing to the VDP control port. And in the rare case that the interrupt occurred between these two, it looks like that was actually messing up the memory selection, and data writing was occurring to the wrong VRAM addresses. So I'm disabling interrupts here and I'm enabling them here. But you can see here we're able to use the shadow registers just fine because of my music tracker doesn't need the shadow registers. And we can actually write to our VDP data ports, reading in from that control port during the interrupt handler. Doesn't affect anything else. So we don't need to disable interrupts for very long at all, just for the VDP memory address selection here. Another thing to note is using the joystick is actually fine on this system. Some systems that was causing other kinds of problem, but on this one, reading in from the joystick, no problem with the interrupt handler. So that's just fine as well. So there we go. So that's how we actually use our interrupt handler. Now, one other thing I do want to just quickly discuss is the ChibiTracks software. So ChibiTracks is a set of include files. It's been split up into various components. ChibiTracks is the main player, but it uses some calculation code. So it uses something called the tweener and fraction 16, and these are for calculating the in-between stages between notes, and I'm planning on reusing the code, so they've been split out. We've also got Chibi Sound Pro, which is the platform-specific sound driver that handles the abstraction between the common code and the platform-specific hardware, which is why ChibiTracks can work on all the systems in Z80, 6502 and 68000 tutorials. And then finally we've got a song file here, which is a binary file. ChibiTracks can also use ASM files if you prefer for some reason, but the binary is probably easier. Now, ChibiTracks has a couple of functions. One is the ability to relocate. When you compile a file, you specify the memory address that it's going to be loaded into, and that is hard-coded into various parts of the code. But if you enable relocation, then that actually doesn't matter, and you can actually load the file to anywhere in memory, and I would suggest you do that unless you're really short on speed or memory, because it adds a little bit of extra code to the player, but it makes using the files so much easier. That was a big gripe with Arcus Tracker for me, because generally the code didn't support that, so I made sure that ChibiTracks was able to do so. The other option we've got here is allow speed to make the music play at the same speed on 50 Hz and 60 Hz systems, because often the music would play at different speeds in that case. I've got it disabled here to save speed and memory, but if you enable that, and if you don't pre-multiply the speed in the export, you can actually change the speed. I can change the speed here, but I can only change it from normal to very, very slow, because the speed calculation has already been done before the binary was exported rather than when it's being played back. So the speed doesn't really affect it as it should. Now, when we want to start our music, we just run the initialization routine for Chibi Sound Pro, which will do whatever the hardware requires to get the music, the sound playing driver set up. And then we load in the address of our song file into Songbase, and we run start song. Now, we would do that every time we want to change the music. That will now play the song. The only other work to do is to run the play routine every time we want the music to update. So in this case, once every 50 Hz, but you could do that on just a crude delay loop or something if the music doesn't need to be particularly accurately speed-wise, or if it's a very simple routine like a title screen where there's no calculations really going on in the background, so you can consistently predict when you need to update your music. Now I will just show you, or let you hear rather, what happens when we change this song speed. So here I'm setting the song speed to 2. Now because the speed has been multiplied into the binary file, you'll notice that it's now playing at basically half speed. If I hadn't done that, then the default play speed would be, I think, 3, and if I changed it to 4, that would change the speed to drop the speed by about a quarter, so that would give a much finer control over the playback speed. But as I say, because it's pre-multiplied in this way, we really don't have any control over it. So there we go. Anyway, so that is how we can use interrupts. That's a brief introduction to the interrupts on the Master System. Pretty straightforward. Same in the GameGear, of course. as I say, just a couple of gotchas with regards to, knowing that you've got to turn on the interrupts on the hardware, and also, just make sure you are clearing that interrupt when it's processed, because those caught me out in the early days. Coming from a system like the CPC where that doesn't happen, the interrupts always happen on that system if interrupts are enabled, so it was something that caught me out. Anyway, go to the website, download the source code and the examples. You're welcome to use them in any way you can, as I always say. Thanks for watching, and goodbye.